This graph plots the adoption of an open-source project called Hermes Agent. In less than 9 months since its creation, it reached 93,000 stars on GitHub, making it one of the fastest-growing AI repositories on the platform. Most coding assistants wrap a chat interface around an API, outputting code and forgetting the interaction the moment you close the window. Hermes takes a different route. It builds a built-in learning loop that analyzes its own mistakes and actively refines its skills with every subsequent use. And it does this using stateful execution that runs on infrastructure as cheap as a $5 a month virtual private server. This specific architectural choice to prioritize local memory over pure compute is exactly how Hermes outpaced heavily funded proprietary coding tools. The system was built by Nous Research, an open-source collective focused on decentralized model training. Hermes represents a shift from ephemeral API calls to persistent, self-hosting environments. To understand why persistence matters, we have to define context amnesia. This is the primary flaw built into standard stateless coding agents. They lack any continuous memory of who you are or what you are building. For developers, this creates a daily tax. You waste the first 20 minutes of every single coding session re-establishing the project's baseline facts before the AI can write a single useful line of code. You have to repeatedly explain your repository's architecture, specify your exact deployment environments, and dictate your internal coding conventions. Tools like Claude Code, OpenAI Codex, and Devon operate exactly this way. They suffer from terminal amnesia, requiring a manual re-upload of your project's mental model every time you open your laptop. Look at this split-screen comparison of the two architectures. On the left, the traditional stateless LLM request processes the prompt and immediately drops the context data. On the right, Hermes uses a closed-loop memory system, feeding results directly back into its contextual baseline. Massive context windows just delay a crash. The blue loop condenses data into procedural memory, allowing recall without overloading the active token limit. True autonomous development is a state management problem. It requires an architectural memory that survives the end of a session. Hermes achieves this statefulness through a mechanical process that generates skills from its closed learning loop. As you work, the agent monitors its own execution across multi-step terminal workflows. It tracks which commands fail, which flags throw errors, and ultimately identifies the exact sequence of actions that leads to a successful task completion. This diagram shows the extraction phase. The system takes successful workflows, strips out dead ends, and compresses the history into a specific .md skill file. When you face similar tasks later, it automatically pulls that precise file back into active context. Over time, this mechanism builds an evolving, cross-session model of your specific coding habits, preferred frameworks, and idiosyncratic syntax choices. To eliminate the cold start friction of training a new agent, Hermes includes an OpenClaw migration tool. It automatically ports your existing API keys, command allow lists, and memory files directly into the new environment. The agent physically alters its own local file system to compound value. Because it relies on its own generated documentation, each session requires fewer tokens, making it cheaper and faster than the last. Because Hermes maintains its own state, the execution workflow completely decouples from your local machine. You can spawn isolated sub-agents and assign them to parallel work streams on remote servers, letting them execute scripts while your laptop is closed. The system uses a centralized gateway process that connects to multiple omni-channel interfaces. You can dictate tasks to the active agent via Telegram, Discord, or Slack from your phone, and it will execute them on your cloud VM. Underneath that communication layer, the system maintains total model flexibility. It integrates natively with over 200 different AI models via OpenRouter. If OpenAI has an outage, you type a single CLI command, Hermes model, and instantly swap from GPT-4o to Claude, or point the system to a local Llama instance. You touch zero code. For enterprise pipelines, this architecture mitigates the risk of vendor lock-in. You maintain the memory locally while treating the intelligence layer as a swappable commodity. Hermes treats language models as interchangeable commodities. By abstracting the LLM layer entirely, it ensures the agent's memory outlives any single provider's API. While the user-facing features explain the project's popularity, the underlying codebase contains a specific layer designed for a different technical purpose. This 3D map highlights two specific files hidden deep in the repository, rlcli.py and trajectorycompressor.py. In machine learning, trajectory compression maps the exact step-by-step route an agent takes to solve a problem. While a developer works, it silently logs every single action, the specific failures, and the manual corrections made to fix the code. The trajectory compressor pipeline takes those raw developer logs and formats them into highly structured synthetic data. This data feeds directly into Atropos, a reinforcement learning environment embedded within the project's submodules. Nous Research built a highly capable open-source tool, gave it away for free, and gained 93,000 users. In doing so, they deployed a massive, crowdsourced engine that passively generates high-quality training data from thousands of professional developers. Highly structured, human-corrected terminal trajectories are exactly the infrastructure required to train the next generation of autonomous tool-calling models. Hermes is a Trojan horse. It functions perfectly as an everyday developer assistant, while secretly operating as a decentralized data collection pipeline for reinforcement learning. We need to ground this in the reality of deploying a hyper-growth project to a production environment. This chart exposes the exact cost of scaling this fast. The repository is drowning in a severe maintenance backlog, carrying nearly 5,000 open issues and over 3,200 pending pull requests. At the operating system level, there is zero native Windows support. If you are on a PC, you are forced to configure and run the entire stack through WSL2. More concerning is the active security debate documented in issue 9179 regarding the agent's container architecture. The community has yet to resolve how to properly sandbox the tool's execution capabilities. Right now, deploying this means giving an autonomous AI the ability to execute arbitrary code directly on an unsandboxed host machine. The daily user experience is also filled with friction. Issue 1083 shows that utilizing the multimodal switching feature frequently triggers bad request errors, breaking the conversation flow. The architectural theory behind Hermes is bleeding edge, but the practical execution remains highly volatile and introduces major enterprise security risks. Hermes represents a sharp duality. It provides a working cure for AI amnesia, but it requires you to participate in a massive, unstable experiment in synthetic data generation. Is a highly personalized, self-improving AI the ultimate developer tool? Or is it just an unsandboxed privacy nightmare waiting to be exploited? Regardless of the current bugs, the open-source community is actively establishing the stateful architecture that proprietary models will eventually have to adopt to stay relevant. The long-term utility of Hermes lies in the reinforcement learning blueprint it provides for future autonomous models. If this saved you time, hit subscribe. We review tools like this every week, so you're always ahead. Now, if you liked seeing how AI agents can learn from experience, you're going to love our breakdown of Crawl 4 AI, the tool that turns any website into LLM training data.